Welcome to a brief overview of SystemVIEW, a truly elegant operator interface solution from Intelisys Software. SystemVIEW provides all of the required functions of an operator interface, including communication with real-time data and control outputs, providing real-time graphic visualization, managing event, alarm, and acknowledgement logs, providing real-time trending and current history trending, an extract of real-time and calculated statistics for a historian. SystemVIEW is a rapid application development solution for operator interface development. The major components of SystemVIEW include real-time server, the display client, the display editor, alarm and event management, real-time trend data management, real-time point editor, and an extract editor. The SystemVIEW real-time server is the first major component of the SystemVIEW application. The RTS is the heart of the SystemVIEW application. It's designed to communicate with one or more I/O systems, that's inputs and outputs. Those could be RTUs, PLCs, or other types of instrument loop communications. Provide a current value display, as shown on the left of this slide, of all values in the system. And we can see on the slide that the point name, point description, point type, PLC address, and current value are all displayed in that current value display. Manage event logging and printing, manage alarm event statuses, alarm logging, printing, and alarm acknowledgments. Provide real-time data to the HMI display clients, or in other words, the actual views the user would be viewing. The real-time data that is shown on the screen is actually coming from the RTS or real-time server. The real-time server also logs trend data for real-time and current history trends. The application typically saves high-resolution trend data for up to 90 days so that it can be displayed on the screen, easily displayed on the HMI screen. Log statistical data to an extract file for a historian. That's a special function built into the real-time server, allowing it to build a long-term historian. Typically, we summarize data for our applications on an hourly basis so that 5, 10, 15, 20 years worth of data can easily be stored in a SQL base. Our next slide here shows the SystemVIEW display client. This is the actual HMI portion of the application, the human-machine interface or operator interface. The display client is a customizable navigation tool used to build linked menus, data displays, and control views. With a simple menu system, overviews, process details, and control views can easily be accessed. The samples shown here are a main menu with a plant aerial photograph, a process overview of the wastewater treatment process in this case, a handoff auto control view where handoff auto switches are actually on the screen. These could actually control the device in the field when properly configured. And an alarm annunciator alarm control dialer control view. This basically is allowing the user of the system to enable or disable alarm functions, whether or not they'll go alarm on the system and alarm to the call-out dialer. The display client also provides access to real-time and recent historical trend data in high resolution, current alarm information, alarm acknowledge and alarm silence, as well as event log and alarm history journal are available from the display client in SystemVIEW. The SystemVIEW Display Client View Editor is also provided as part of the standard application. In the View Editor, the user can easily and quickly create menus, process views, and control views. Palettes for pick-and-choose functions are available in the View Editor. Color and format, edit, tool palette, digital input, digital output, analog input, and analog output palettes are all included. Digital pictures and objects can easily be added and scaled to each view. In the SystemVIEW Editor, the user can quickly and easily create dynamic text objects, dynamic objects, and control objects. Smart Server also collects statistics on runtime, start counts, totals, etc., and can expose that data to user-created views. We see that when we look at the dynamic text configuration. We can see that even for a digital an input, you can keep statistics such as runtime hours, runtime minutes, sets, resets, that type of information can be used for displaying runtime, accumulated runtime on a motor. In the next little panel here, we look at the dynamic fill for an ellipse. And here you can see you can scale the filling of a tank, elevated storage tank in this case. And then lastly, we show a event string for a digital output object, which in this particular case is a handoff auto switch, where we're triggering 2 bits in the PLC with any control function. In a typical SystemVIEW operator interface, you might start out with a main menu screen, which would allow access to a system overview screen and or control screens. In this particular graphic, we're showing the menu screen and access to a system overview screen, basically showing the status of all of the major equipment in a small water system. We're also showing access to a control screen for one of the water treatment plants in this particular case, where there's 3 wells and 2 booster pumps involved. Also, we might access a trend screen, in this case a tower trend screen, showing the elevated tank levels in those tanks for the last 12 hours. Another important component of the SystemVIEW operator interface is the alarm server function. The alarm server manages current and historic alarms and events in a monthly database file. The alarm server then combines the current and historic files so that an alarm history query can easily be made for a specific alarm point over an extended period of time. In this case, we're just showing an example of a couple of points that were set and reset or alarmed over a period of time. The trend server component of SystemVIEW makes high-resolution real-time and recent history, usually 30 to 90 days, with the data available to the display client for trend displays. Trending can easily be set up to pan and scroll through the trend files. The SystemVIEW point editor is actually part of the real-time server application. The point editor is used to set up communication with I/O devices. Various types of points can be set up in the system, and the block diagram on this view actually indicates analog inputs, analog outputs, digital inputs, digital outputs, units with and without scaling, as well as some special output for extracting to report view, extracting to maintenance view, and in this particular case, a link for a DDE device on the network. Several point configurations are shown on here. The digital input for a DAF separator recycle pump 1 run signal, basically a DI or digital input showing the address and other information. And there's also a analog input or AI2 analog input with scaling is shown, and this is an elevated tower level. And we can see that the elevated tower level has a multiplier or scaling of 0.1, so we're multiplying times 0.1 the value we read out of the PLC. We also are showing analog input calculation. In this case, we're taking a flow, which would be in GPM, multiplying it by 1440 minutes per day and divided by 1,000,000, giving us a value of MGD, or millions of gallons per day. Also part of the real-time server is the extract editor. And the extract editor in this particular case is shown extracting 4 different points to the historian, if you will. In this case, we're actually extracting a calculated value, which was the sum of kilowatts from MCC1, MCC2, and MCC3, so possibly the mean circuit breaker total kilowatts. Real-time data can be collected when communicating with various devices. OPC, DDE, and serial communication via Modbus and AB protocols are available, and that's actually with the real-time server. The smart server technology mirrors the real-time values. Summary data is calculated in real time. This data conditioning allows the user to save the data in the proper format, and that's important when you're looking at doing daily shift reports, daily reports, weekly, monthly, yearly reports. We need to be able to summarize the data properly so that the time series data can be pulled out onto those reports and charts in a proper format. Extracts are made on a timed schedule or based on an event. Typically, an hourly event might be $= 59. That example, at the end of every hour, when the minute equal 59, the extract would be fired and the data would be collected. Multiple timed extracts can be employed by second, minute, hour, day. This creates a time series data for import to the long-term database, historical database. SystemVIEW, offering simple elegance in an operator interface solution. Again, the summary of SystemVIEW functions include communication with real-time data and control functions, provision of a graphical user interface displaying real-time data, management of events, alarms, and acknowledgement logs, providing real-time trending and current history trending, extracting real-time and calculated statistics for a data historian. All of the features you need in a simple operator interface in one package. Full set of development tools is included with each and every application. Give us a call at Intellisys or go to our website to find out more about SystemVIEW, the elegant operator interface.